Hello, welcome to this new lecture of the course Transportation Network Analysis. So, until now we have been talking about traffic assigned problems, but all of these traffic assigned problems that we have been focusing on were deterministic. So, there was no component of uncertainty present in them. However, there can be some uncertainty associated in traffic assigned problems. For example, the travel times may not be exactly known to people and so on, and because of that, it may be required that the modeling process of this user equilibrium problems and so on should also change when there might be such uncertainties. Okay, so our target for the next few lectures will be to move towards stochastic user equilibrium, where we will be considering stochasticity in the travel times. But before we finally go there, we need to uh, learn a few concepts and tools that will be useful in finally reaching that stage. So, today we will be discussing about discrete choice models and their applications. So, let us talk about these kind of models, what they are. So, we will be formulating the route choice as a process of selection among alternative paths on which the travel time is random. Okay. So, suppose a person has to go from an origin to a destination. So, he has a set of routes that are available. These are different alternatives that are available. Now, given that the travel time might be random across these different paths, so when such a thing happens, then how does the decision making change? Okay, so that is the main target here. So, for that we will be using these discrete choice models. So, Daniel McFadden had won Nobel Prize in 2000 in economics for his pioneering work in developing these discrete choice models. These models describe individuals' choices among competing alternatives. Okay. And the hypothesis of discrete choice models is that an individual's preferences towards each alternative can be described by an attractiveness or utility measure associated with each alternative. Okay. So, here we are assuming that every individual will be associating some attractiveness or utility towards each alternative that is there, and depending upon the value of that attractiveness or utility, it will be getting decided whether a person chooses that alternative or not. Now, utility is a function of the attributes of the alternatives as well as the decision maker's characteristics. Okay. So, just to give you an example, suppose I have to go from the university to say a place in a city, and suppose I have two options for traveling, one is option A, the other is option B. Okay. Now, while I decide that which option I should take, there might be various factors I might be considering. So, for example, travel time can be one factor which I may take into account. There can be other factors as well. For example, it may be possible that the option A that I choose, even though it might be offering shorter travel time, it might not be very comfortable, okay, because of various reasons and so on. Okay. So, there can be other factors also which might be associated while a person makes these decisions. Okay. So, these factors are referred to as attributes. Okay. So, these are the different factors which affect the decision making while there are different alternatives. And the other thing is that this utility or the attractiveness of particular alternative might also be varying with the decision maker that we are focusing on. For example, my focus towards the travel time and discomfort might not be the same as another person's focus on travel time and discomfort. Okay. So, for example, there might be some other characteristics which might be particular to me that might also influence whether I choose a particular alternative or not. Okay. So, here it is saying, for example, travel time across routes between an OD pair can be one such attribute. Okay. So, this is one factor which kind of influences decision to travel across different routes if we are starting from a given origin to a destination. So the decision maker is assumed to choose the alternative that yields the highest utility. Okay. So every decision maker will choose that alternative that will offer the highest utility or attractiveness. Okay. So we will be referring to these terms like attributes and factors interchangeably. So they will mean the same in this discussion. Now one thing is that these utilities cannot be observed or measured directly. Okay. So the attractiveness that a person attaches to a particular alternative cannot be observed or it cannot be measured directly. Okay. So there might be a few factors which we might be aware of that a person might take into account while he or she is making the decision, but it can also happen that there might be other factors also which might be influencing their decision, but we might not be aware of. For example, when I am saying that the two factors or the attributes that I consider while choosing which option to choose while I am going from this particular place to another place in this city. So right now we are just thinking of travel time and discomfort, but there might be other factors as well which might be affecting an individual's decision on which alternative should be chosen. But the analyst who is actually trying to determine that what factors will be affecting a particular individual's decision, so he may not be aware about the other attributes also which might be affecting an individual's choices. Okay. So not all the attributes can be observed, okay, that might be affecting the individual's choices, and therefore this utility that we actually associate or the attractiveness that we associate with each alternative is considered to be a random quantity. Okay. So to give you an example, suppose there are suppose two alternatives that we have. Suppose u1 is the utility that a person attaches to the first option, okay, or the first alternative. So suppose u1 can be a function of beta 1 plus beta 2 times t plus beta 3 times d plus some error term here E1, and suppose the utility of the second alternative is b dash 1 plus beta 2 dash t plus beta 3 dash d plus E2. Okay. So now here t is the travel time which is influencing these two options or the alternatives that I have, and d is suppose the measure of discomfort or the comfort that is associated with each of these alternatives options. Okay. So this part is some function which is deterministic. So this is something which is exactly known, but then there are these terms also like E2 and E1 here which are random components. So these are taking into account some unobserved factors which might also be affecting an individual's decision making process. Okay. So since we may not be able to consider all the factors that might be affecting an individual's choices, so that's why there are these error terms E1 and E2, and they are considered to be random or stochastic. Okay. And therefore this overall quantity, both of these utility values for each of these two options or alternatives, so they will be considered to be random because of the presence of these error terms here. Okay. So that is why it is being said that the utilities themselves are modeled as random. Okay. So the discrete choice models give only the probability with which alternatives are chosen and not the choice itself. So since the utility of choosing the first alternative is a random quantity and the utility of choosing the second alternative is also a random quantity, we cannot say with 100% accuracy that always one of these utilities will be higher than the other one, right. For example, if this u1, which is the utility of the choosing the first alternative, suppose it is a random quantity, that suppose this varies uniformly from this interval minus 1 to 1, okay, and u2 is again another variable which varies uniformly at random in this interval, suppose minus 2 to 3, okay. So, now if I randomly pick a value of u1 from this interval, okay, suppose I pick the value to be equal to 0, and suppose I randomly pick a value from this interval for u2, and suppose it comes out to be 2.5, okay. So, in this case the value of utility 2 is higher than the value of utility 1, because 2.5 is greater than 0, okay. But it can also happen, suppose that if I again randomly pick a value from this interval, suppose it comes out to be 0.5, okay, and suppose I again randomly pick a value from this interval, it might come out to be suppose minus 1, okay. Now in this case 0.5 is greater than minus 1, okay. So sometimes it can happen that the utility 1 might be greater than the utility 2 and vice versa, okay. So therefore we cannot say for sure that always the utility of one alternative will be higher than the other. What we can only say is that what is the probability with which the utility of the first alternative will be higher than the utility of the second alternative, and that will actually tell us the probability of choosing this alternative, okay. And that is why in discrete choice models what we can say is that that if there is a large population of people and every person suppose extracts a particular value of the utility of first alternative u1, and the same person also extracts the value of the utility of the second alternative u2 from the distributions that are given. So then depending upon what values are picked, for example like if this is the case, then he will be deciding to choose alternative 1, whereas if it was this the case, then the other person might be choosing alternative 2 and so on, okay. So that is why what we can only say is that what is the probability with which different alternatives can be chosen, not that a particular alternative will always be chosen as compared to the other one, okay. So this was not the case, for example when we were discussing about deterministic traffic assignment, because there we could say for sure that, for example, if there are two paths between an origin to destination, and suppose only one of the paths is getting used, so it can happen that the travel time on the used path might be less than the travel time on the unused path. So there we could say for sure that travel time on one of the paths is always lesser than the travel time on the other path, and therefore everyone was deciding to choose one path only, okay. But this might not be the case in this kind of scenario, okay, when there is randomness in the travel time. So therefore what we can provide as output from these discrete choice models is the probability of choosing route 1, probability of choosing route 2 and so on, okay. So let us represent these utilities of different alternatives. Suppose there are k alternatives by this vector u here, this has been represented by bold here, so it has k components here, okay, and this is the set of all the alternatives that are present by bold k, okay. Now let us represent by bold a the vector of variables which include the attributes of the alternatives and the observed characteristics of the decision maker. So for example when we had considered t, d, that is travel time and discomfort, these were two attributes that we were considering while modeling that decision making process between the two options that we had, okay. So these t and d are the variables that are influencing the decision making process here, okay. So the utility of each alternative will be function of this vector a, which is the vector of variables which include factors of the attributes of the alternatives and the observed characteristics of the decision maker, okay. So the utility of each alternative is expressed as a random variable which is consisting of a systematic or a deterministic component Vka and an additive random error term, this epsilon Ka, okay. So for example when we had written that u1 is equal to beta 1 plus beta 2 times t plus beta 3 times d plus some error term here. So, this is the systematic or the deterministic component of this utility, and this is the random error term. Okay. And these parameters t and d, these are actually these parameters A, which are the attributes of choices that we have here, or the factors that are influencing this decision making process. Okay. So, for this first alternative there will be particular value of t. Okay. Similarly, there will be particular value of d. Okay. So, there will be particular value of u1. Okay. Similarly, we can write down the particular value of u2 also. Okay. So, this is what is being said here, that for each alternative k, uka is equal to vka, that is the systematic or the deterministic component, plus the additive random error term that is here. Okay. Okay. Note that the random component of the utility satisfies that the expected value of this error term is equal to 0. Okay. So, we will be assuming that the expected value of this error term is equal to 0, and therefore, if we have to determine the expected value of this utility here, so if we take expected value on both the sides here, so then we can write the expected value of Vka plus this quantity here, and then this will be equal to the expected value of Vka plus the expected value of this error term here. Now, since this is equal to 0, so therefore, this is just equal to the expected value of Vka. Okay. Now, since Vka is a deterministic quantity, so therefore, its expected value is equal to just Vka here. Okay. So, therefore, the expected value of this utility is equal to Vka here. Okay. So, this uka is known as the perceived utility and vka is known as the measured utility. Okay. So, this quantity can be measured in the real world, okay, but not this one. I mean, effectively what I mean is that these attributes values that we kind of associate in this Vka, those can be exactly be measured. Okay. So, let us denote the probability that alternative k is chosen when the attribute vector A is there as pka here. Okay. So, pka is also known as the choice function. So, what is the probability of choosing this choice k or the alternative k? Okay. Note that the probability that alternative k is chosen given this vector A should be understood as the fraction of individuals in a large population, all members of which are characterized by A who choose alternative k. So, what does this mean? That suppose if there are two choices, okay, that we have, or two alternatives. Now, suppose the probability of choosing the first alternative is suppose 0.6, and suppose the probability of choosing the second alternative will then have to be 0.4. So, then what it means is that if suppose there are 1000 people in a given population who have to make decisions between these two choices or these two alternatives, then what will happen is that around 600 individuals in this population will be choosing the first alternative, whereas 400 individuals will be choosing this second alternative here. Okay. So, why is this the case? Because see, every individual that will be coming here, so he will be randomly getting one value of u1, the utility of the first alternative, and randomly getting the utility of the second alternative u2. Okay. So, these u1 and u2, since these are random quantities, so these are like samples that are picked from the distribution of u1 and u2 that we have. Okay. So as we have seen that since u1 and u2 are randomized quantities, so sometimes it can happen that u1 may be larger than u2. If that is the case, then the first alternative will be chosen. If it's the other case, then the second alternative will be chosen, right? Now since the probability of choosing the first alternative is 0.6, so it will happen that out of 1000 people, around 600 people will be getting this first alternative as the best choice, because they will be seeing that the utility of that alternative is higher than the utility of the other alternative. Okay. So pk is the probability that uk is higher than the utility of any other alternative. That is, mathematically what it means is that probability of choosing the first of kth alternative is equal to the probability that the utility of this kth alternative is greater than or equal to the utility of all the other alternatives. Okay. Now the choice function pk has all the properties of an element of a probability mass function. So what are those properties? First is that this probability choice function has to lie between 0 and 1. So we know that that always holds for any probability, and the sum of the probabilities across different alternatives should equal to 1. Okay. That is, the if suppose the probability of choosing the first alternative is say 0.6 and then there are only 2 alternatives, then the probability of choosing the second alternative will be 1 minus 0.6. Okay. Okay. So just to remind again, so this discussion of discrete choice models and stochastic user equilibrium that we will be doing in the next lectures, all of this is again having a good discussion from the book on urban transportation networks by Joseph Sheffy. So I would suggest that you also refer to that. Okay. Although the slides are complete in that sense, but a book can provide a lot of other details also, and it might be able to provide some more examples, exercises and so on. So once the distribution of the error term Ek specified, the distribution of the utilities can be determined and the choice function can be calculated. So let us consider an example to understand this. Suppose there are only 2 alternatives. Okay. Suppose the utility of the first alternative is 3 plus this error term and the utility of the second alternative is 2. Now for simplicity in this example, it is being assumed that the utility of the second alternative is a deterministic quantity 2, although whatever examples or applications that we will be focusing on, they will always be assumed to have a randomized value of the utility. So it will not be a deterministic quantity. Okay. Now suppose if you have to determine the probability of choosing the first alternative. So what is the probability of choosing the first alternative? It is equal to the probability that the utility of the first alternative is greater than or equal to the utility of the second alternative. Okay. So mathematically this means this here. So probability that 3 plus this error term is greater than or equal to 2. Okay. And that means that probability that this error term has value greater than or equal to -1. Okay. Now you can see that depending upon what is the distribution of the error term here, we can calculate this probability exactly. Okay, that is what actually was said before this example started, that once we specify the distribution of the error terms, then we can actually tell what is the probability of choosing different alternatives. Okay. So let us assume now that the density of this error term is uniform between -2 and 2. That is, this error term is a variable which is distributed uniformly and continuously from the interval -2 to 2. Okay. So then the density function for this will be given by this here, that is, if this error term is lying between -2 to 2, so then its probability density function is equal to 1 by 4 and 0 otherwise. Okay. I hope you can guess why there is a value of 1 by 4 here. The reason being that if we integrate this probability across the whole interval from minus 2 to 2, this integral should come equal to 1 here, and that happens because if you multiply 1 by 4 with the length of this interval, what is the length of this interval? 2 minus minus 2. So, 1 by 4 times 4 is equal to 1. Okay. So, therefore, there is this 1 by 4 value written here. Okay. Now, if this error term is uniformly distributed from minus 2 to 2, so the probability that this error term will be greater than or equal to minus 1 will be what? It will be equal to 3 by 4. Why? Because the probability that it will be taking the value from minus 1 to 2 will be equal to what? So, it will be equal to 3, because this 2 minus minus 1 is 3 divided by 4, which is the overall length of this interval. So, this is 3 by 4, which is equal to 0.75. Okay. Now, if the probability of choosing the first alternative is 0.75, then the probability of choosing the second alternative will be 1 minus of 0.75, which will be 0.25. Okay. Therefore, 75% of the individuals will choose alternative 1 and 25% of the individuals will choose alternative 2. Now, you can hopefully understand that what will happen is that, see, the utility of the second alternative is always equal to 2, but the utility of the first alternative is 3 plus this error term that is there. Okay. Now, sometimes it can happen that this error term can take negative values, and because of that this u1 can be lesser than u2. Okay. So, for those cases alternative 2 will be chosen, but for the cases when this whole quantity is larger than 2, then the first alternative will be chosen. Okay. So, if we have a large population, so then that means that every time an individual, whenever he will be making this decision between choosing which alternative to take, then he will be randomly picking one value of u1 from this distribution of 3 plus error term, and for the second alternative the utility is anyway deterministic, so it will be 2. Depending upon what is the comparison between this value that he got and this 2 value, he will be deciding which alternative to choose. Okay. So, therefore, this is the case for this example here. So, let us now start towards a very important discrete choice model. This is called multinomial Logit model. So, just to mention that we will be discussing two discrete choice models here. As you can see that the distribution of the error term actually defines what is the probability of choosing different alternatives. So, these two discrete choice models that we will be discussing, the first one will be this multinomial Logit model and the other one will be multinomial probit model. So, the way they will be differing is in terms of what assumption that they make in the error terms. Okay. So, this multinomial Logit model is one of the most widely used discrete choice models. Okay. In short or in informal way, it is also called the Logit model. So, in Logit model, the random terms of each utility function are independently and identically distributed Gumbel variates. So, this independently and identically distributed is sometimes referred to as short in IID. Okay. And this is important, I mean you should kind of know this, that what it means is that the distribution of the error term of each alternative here in the Logit model is a Gumbel variate. This we will see what it means, but this distribution is the same for every error term in different alternatives, and these different error terms are independent of each other. I mean the error terms, they are coming from independent distribution, so that is important. Okay. So, this Gumbel variates is given by this cumulative distribution function. So, the probability that the value of this variable will be less than or equal to some value omega is given by e to the power minus e to the power minus omega plus capital E, where this E and capital E are standard constants here. Okay. So, we do not need to worry much that how did this come here, but this is kind of given. So, given that we have this cumulative distribution function for the error term, we have to now see what does the probability of choosing different alternatives mean and so on. Okay. So, if you remember, the probability of choosing the first alternative, suppose there are two alternatives only, is equal to the probability that the utility of the first alternative is greater than equal to the utility of the second alternative. Okay. So, if we can write it in form of this V1, which is the so this is V1, okay, and this is U here. This is systematic term plus the error term here greater than equal to the systematic term of the second alternative plus the error term of the second. Okay. So, if we take the error terms on one side, so what it means is that E2 minus E1 is less than or equal to V1 minus V2. Okay. So, now that the both of the error terms here are given by this cumulative distribution function and they are independent variables. So, depending upon what is the overall distribution of this difference of the error terms, we can determine the expression for the probability of choosing the first alternative. Okay. So, we will be not worrying about this derivation here, but we will be directly providing what is the expression for the probability of choosing these different alternatives in the case of Logit model. Okay. So, this we will be doing in the next lecture here, and today we will stop here. Okay. So, thank you.